Welcome back to the Scotti-BYTE channel, and this is Scott. I want to tell you all that I appreciate each and every one of my subscribers, and I hope you'll pass the word on the channel. So today I want to discuss Ethernet NIC issues that I've been having. So a couple of months ago, I added a 10 gig NIC or network interface card to my Dell desktop. And when the system boots, it enumerates the PCI Express bus and then detects the built-in 1 gig NIC and also the new 10 gig NIC, but it does so in a random order. So I really don't want to disable that internal NIC in the BIOS because it's the only one that performs PXE booting, and I used that in my video about iVentoy, where I talked about how to PXE boot certain utilities. So in everyday use of my desktop, I really didn't need the built-in 1 gig NIC, and instead I'd rather use the 10 gig NIC as a regular device. So what is my solution? Well, the IP-link set ENP3S0 down command is not boot permanent, and unfortunately, it's not always ENP3S0. At times it's been ENP4S0 and even ENP5S0. So the device name changes according to how the PCI Express bus enumerates the hardware devices. So when the system boots, the bootloader loads the Linux kernel modules into memory and it starts the kernel. So a routine or a script called init ramfs bundles a set of directories into a single archive that becomes the root file system. So initrd is an in-memory root file system or RAM disk that has all of the necessary tools, scripts, and kernel modules that are mounted before control is passed to the init application on your root hard drive. So today we're going to learn how to use init ramfs to modify the loaded kernel modules that the system boots with. Here we are for the primary display on my desktop, and you can see that I have a GNOME extension up here which calls out the address of 172.16.1.224 as my LAN address. But if I click the drop-down menu, you'll see that I have a Qualcomm Atheros Ethernet and an Aquantia Ethernet. Well, the Qualcomm Atheros is the built-in integrated NIC on the motherboard, and the Aquantia Ethernet is the new 10 gig card that is on the PCI Express bus. If we go down and click on settings, you see that the Qualcomm is connected at 1 gigabit or 1000 megabits per second, and the Aquantia Ethernet, the add-in PCI Express 10 gig card, is connected at 10,000 megabits per second or 10 gigs. So we want to identify this 1000 megabit per second, the Qualcomm, and if we click on the gear, you'll see that it's assigned the address of 172.16.1.224, just like we see above with the GNOME extension. So let's go take a look at this from a different perspective. If I do an ifconfig command here at the terminal prompt, you'll see that I have quite a few Ethernet devices, and that's because I'm actually running an Incus server at my desktop. So if I scroll up here, I can also see that I have my Bridge 0 device, which is covered in Incus containers step-by-step, and it's assigned the address of 172.16.1.225, and it actually is connected to the device ENP4S0. Unfortunately, when the system reboots at various times, this device can be ENP3S0 ENP4S0, and I've even seen it as ENP5S0. And so since that device name changes, that makes it pretty difficult to be able to set it up with NetPlan. And initially, just like my Incus servers that are covered in Incus containers step by step, I actually have my ENP4S0 not being assigned an address as you see here, and instead it's used as the parent device for the software switch bridge 0. But that really means that ENP3S0 is not my primary LAN device, nor do I want it to be. So one workaround to this is I can go ahead and disable that device with the command sudo IP link set ENP3S0 down, and that will disable the device. And in fact, if I do an ifconfig now, you'll see that as I scroll up, we have an ENP4S0, but we have no ENP3S0. And if we look at our GNOME extension up here, it now correctly reports the address for bridge 0, which is 172.16.1.225. Also, if we click the pull down, you notice that it does not list the Qualcomm Ethernet device anymore. It just lists the Aquantia 10 gig device. And if we go into settings, we'll notice that it says that the cable is unplugged for the Qualcomm device. So this would seem to be our solution. However, if I reboot the system, ENP3S0 comes back, and it comes back online once again. We can begin to see the solution to this by listing the devices on the PCI bus with an LSPCI. And you'll see here as we look down that I do have two Ethernet controllers. One is the Qualcomm and the other is the Aquantia 10 gig device. This 10 gig Aquantia device that's in my Dell desktop is a PCI Express 4 device, and it is sold by TrendNet, and this is the device here on Amazon. And as you see, it has an SFP here, and I bought a fiber SFP that's connected off to my fiber switch for my 10 gigabit connection. I really didn't want to disable the 1 gigabit Qualcomm integrated Ethernet NIC in the BIOS, and the reason for that was because I wanted to be able to Pixie boot iVentoy and be able to access programs like Redo Rescue. So if we go just a little bit further with LSPCI and do an LSPCI-verbose, now we have a really verbose listing of the things on the PCI bus. And here I see my Aquantia device, which is the 10 gig device that I want to keep active on the system. But if I scroll up just a little bit, I can see the Qualcomm Aetherios E2400 gigabit Ethernet adapter, which is the integrated adapter. So as we look at this device, we can see that it loads a kernel module called ALX. The way we can disable that Ethernet controller is by editing a file called /etc/modprobe.d/blacklist.conf. And this particular configuration file has several items that are blacklisted, which means don't load kernel modules for those particular devices because either they cause a conflict with the system or some other issue. At the bottom of this file, I'm going to go ahead and add a comment that says disable Qualcomm 1 gig NIC on Bootstrap and blacklist ALX, which is the name of the kernel module to load that particular device. Now I can do a Control-O and enter to write the blacklist file out and a Control-X to exit the editor. In order to update the CPIO formatted RAM-FS file system on disk, we're going to need to do a sudo update -init RAM-FS, and then the -u means don't recreate it, but instead update it, and that will go ahead and generate a new archive, and that archive will be used to boot the operating system every time from now on. At this point, the only thing left to do is to reboot the system with a sudo reboot now. Now that we're rebooted and back up and running, if I come up here and click, you notice that there's no longer a second device and it just says wired connected. Likewise, if we go into settings here, we only have one wired connected device, and it is the 10 gig device. The 1 gig device does not show up even offline because its kernel module is not loaded. And likewise, if we do an if config and we list out all of the devices, there is an EMP4S0, which is the 10 gig internal device, and it is the parent device for the Bridge 0 virtual switch, but there's no ENP3S0 or ENP5S0 listed on the system anymore. However, if we boot from another operating system or boot Pixie, for example, that 1 gig Ethernet device will be available and will be accessible. And just as one final detail, if we do an LSPCI to list out the devices on the PCI bus, you'll see that we still have the Qualcomm Ethernet controller listed here, but since it does not have a kernel module loaded, it has not been configured. So in summary, the init RAM-FS script creates a CPIO archive that is compressed by gzip. And somewhere back in the 2001 timeframe, the developers of the Linux operating systems decided that a CPIO archive and not a tar archive would be used to create this RAM disk. And ever since, that's kind of caught on. So init RAM-FS creates an early RAM-based user space, which is loaded into TMP-FS before control is passed to the real root file system on your hard drive. So in this tutorial, we modified the CPIO archive with update-init RAM-FS to blacklist, or otherwise known as not load the kernel module for the built-in NIC. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.